So yes, hello everyone, it's me Abhay, and today we are going to continue with the bits manipulation lecture 3. In this lecture we are going to study about, firstly we are going to discuss the homework which I have given in the lecture 2. Then we will study about the how to find the missing number in a permutation. Then we will check how to find two odd occurring elements in a given sequence. Like in the previous video we studied one odd occurring sequence number in a sequence, right? And then we will study about the count set bits in a number. In this topic we will study about the two methods to find, and then we will study about the how to check whether a given number is a power of 2. So before starting, this video is a collaboration with the Newton School. So before getting started, let's know about something about the Newton School. So Newton School is an platform which teaches you full stack development from absolute basic to advanced level. So best thing is that they didn't take any fee until you get placed in the top companies. And yeah, they provide you free classes, industry projects, and the another best thing is that they provide you personal mentoring, like one-on-one guidance, and the mentors are placed in the top companies. You can check out here, and the positive reviews are given by the students. Yeah, you can definitely check out here. And they have a cool feature called as Launchpad, where you can sit and write code, and you will get a certificate of completion and best instructors and many more things. And yeah, these are some free courses from the top mentors. You can definitely check it out. All the links will be in the description. And if you have any questions, you can read out the frequently asked questions from their website, on their website. Yeah, so let's get to our lecture right now. So what was the homework? Homework was like we are given a number and we have to check the current bit of a number is set or not. Like we are given number 1100110, and we have to check whether this bit of number is this bit is set or not, right? So we did it with the left shift, but the homework was do it with right shift, right? How to do left shift is like take a number 100, 100 and move 1 to here and do bitwise AND. If the number is equal to 0, means if the result is 0 means that bit is off, otherwise that bit is set, right? How we can do it with right shift operator, right? What we will do, we know like which position we have to check, right? If this position is kth, then what we will do, we will shift this kth bit to first position, means we will do uh, k minus 1 shift, means n right shift how many times, k times, right? Then this number will something like become 1 0 0 1 1, yes, all these are zeros. Okay, now what we will do, now we will direct do the AND with 1, because we have to check this number, this is as a first place, and directly we can do the AND with 1. If the number is, if the answer is 1, the set bit is, then the this bit is set, otherwise that bit is not set. So this is like a quick question which you can do it, right? So let's move on to the today's lecture. The first question we are going to study, like find the missing number in permutation. Like if the permutation means number like 1 2, permutation of length, let me 6 5, okay, there is a permutation of from 1 to n, and here reference to 6, okay, inclusive, right? So we have to find the missing number in a missing number in this sequence. So how can we find? Just take 2 minutes and think, right? So yeah, yesterday we, in the previous lecture we study about the how to check the the implementation of bitwise XOR, like how we can use that. So what we will do, we will, like we know, like if two numbers are same, the bitwise XOR of that number will be equal to 0. So how we can use that in this question? If let me write the full array 1 2 3 4 5 6, right? And we know that this number is not present. So what can we do? Like this number is, this array is given, and this array we know because this is a permutation, and one number is missing. So what we will do, we will XOR of these both, and like these will get cancelled, and only this number will be remaining. This will be get cancelled, and this number will only be remaining. So what we will do, we will do XOR of all these numbers, and at last we will get only the number which is missing in the permutation. So like this is also a quick question. Here you can use the bitwise XOR. So all this question will be available in the sheet, like practice sheet, which you can practice at home after watching this video, right? Then the question comes, the two odd occurring numbers in a sequence, right? This is a good question. If the sequence be like 1, 2, 3, 4, 4 and 1, right? Then the answer should be 2 and 3, because these are two numbers which are occurring only one times, and all the rest numbers are occurring in pair, like this have like this is in the pair and this is the pair, right? So we have to output 2 comma 3, right? So how we can do it? With the bit operator. Otherwise we can just count the frequency of all the array, and the number who are getting the frequency equal to 1, we can directly print it out. But we have to do in complexity equal 1. So how we can do it? Space complexity, right? So just think, and we are going to continue. So what we will do, we will first take the XOR of the full array. What will be the XOR of full array? That will be definitely 2, something value called 2 XOR 3, right? And because these cancel with this and this is cancelled with this, right? And we will get this only. So this is right now the XOR of A, right? Now what we can do, like we know the property of XOR, like if there are two different numbers, like this is 0 and 1, or 1 or 1 or 0, we will get the answer alag alag 1, right? In the both case we will get the answer 1. So what we will do, we will find the rightmost set bit, right? So if I do the XOR of 2 and 3, like 2 is bit representation of 2 is this, and 3 is 1 1. If I do the XOR of this alag alag 1, same 0. So this is the XOR of 2 comma 3. And now what I will do, XOR, like now I said I have to find the rightmost set bit, right? Here I can find the rightmost set bit is this. Let's denote is R. Now what I will do, I will break this array, this initial array, into two parts. The first part will be which have this rightmost bit as set, and another will be not set, because as we know, when after doing the XOR, when we get a number set, then this is the only case, like if first number has 0 or another has 1, or vice versa, like first have 1 or another have 0, then only we are getting the 1 after doing the XOR. So I will find the rightmost set bit and break the array in two cases. Like first case will be all the values having end as 0 and all the values having end as 1, right? And all the other number occurs in pair. So what will happen in this pair, all the numbers having zeros in the pairs, when I will do the XOR afterwards, then all the number having in the pairs will get cancelled, only the one number will remain. Similarly in this case, because after doing XOR of equal to 1, then these two numbers get divided into two different pairs, right? And in each pair there will be only one number which occurs differently. Means I have break this question into the previous question, find the odd occurring number in a given sequence. So this is the way we can do it, right? So this question will also be present in the sheet. You can open the link and solve it. Like I'm not going to do that implementation right now, because that will be like a homework, like brainstorming work, how you can find that bit and how you can implement this previous lecture logic, right? So yeah, this is the way we can do it, find the 2 and 3. So let's move on to the next topic, right? Then here comes the count set bits. Like it is like an important topic, like I will do the implementation right now. So set bits, counting the set bit of a number. If a number, let's suppose a number is 6, then the number then the set bits, then its bits representation is 1 1 0. If we have to count the set bits in a number, then it will be 2, because we have only 2 bits set in this number at this position, right? Now we have to count this. So what we will do, like we know like this position refers to 1 and this 2 and this 4, then what we will do, we will divide this number by 2 until it becomes 0. So like firstly it is 6, right? So we will check the last number, the last bit is 1 or 0. How we can check is we will do the AND with 1, like we will do the AND with 1. AND with 1 refers to means this number is even or not, right? I will do the AND with 1, I will get 0, so means I'm not going to add anything, like count equal to 1, so count is initially equal to 0, so 6 will become 1 1, which is 3, means I have done 6 by 2, it will become 3. Now I will check for 3. Yes, 3 has the last bit equal to set, so I will do count 1, then it will become 2. Okay, like I will divide it by 2, then it will become 1 0 1, right? Then I will again check whether the last bit is set or not. Yes, it is set, so I will increase the count, it will become 2, because we are going by this side we are dividing by 2, and yeah, so let's implement this logic. Like it is like a quite brute force type, brute force not, yeah, but we can say. So let me just, yeah, so if we are given a number, let's take this number input, right, and we have to output count set n, sorry, right, let me define a function. Right, then what I will do, firstly I will create a count and make it 0, and now what I will do, like I will run a loop while n is more than 0, like at 0 it will break, and if n and 1 is true, means that number is odd, the last bit is true, then I will increment the counter. Otherwise at if the else, there is no need for else, because if the last bit is 0, then I have nothing have to do, then I will do n divided by 2, or you can write it as n right shift equal to 1, right, because we are shifting the 1 to the right side because divided by 2, right. Then after that we will return count, right. Let me check this, let us run this question, right. If let the input be 31, as we know 32 is 6-bit number, like has 6 bit, so 31 definitely will get the answer is 5. If I check for 30, because I have -1, did -1, then the answer should be 4, because 30 has a 4 set bits, right. Yeah, definitely. So this is like an the thing like which we come, like we will go every set and check every set is 1 or 0, like that way. Like there is a more efficient way, which like this has a complexity of order of set number of bits, right. Like number of bits which the number have n as number of bits of n, it has a complexity of that. But there is one more efficient way, like there is that's called as Bryan and Carrington algorithm, that work as like this way. If the number given number is 6, okay, 1 1 0, then what it will do, it will, its complexity is count of set bits only, right. So it uses the last bit only, okay. Like if the number is 6, when I do the -1, what it will do, it will change the rightmost set bit equal to 0 and all the previous bit equal to 1, and this all will same. And when I do 6 and 6 minus 1, what it will become, it will like 1 1 0, and with 1 0, and we don't need, like it will become 1 definitely, yeah. But this bit, the rightmost set bit in the given number, will become 0. So after doing the AND by this number, that number will become 0, and there is no effect on the previous full the sequence of the binary representation, right. then this will become 100, right? And again we will do this will become 0, and again we will increment the count, right? This will work like this. If the given count is 0 while n is more than 0, so let me just uh, okay, so every time we will just increment the counter, like how many times, how, like I have said, this has a complexity of the set bits, so this loop will run only uh, until the number has a set bits, right? I will do every time the count plus plus, and n is equal to n and right, n minus 1, sorry, right? And at last I will return the count. So let's check it, like if for 31, as we said, the answer is 5. Let's check. Yeah, it is 5. And for 30, the answer is 4. Yeah, it is 4. So this is like a more efficient way, that the previous works on the number of bits in a number, and this work was only for the number of set bits. And here comes, like, you can also use this built-in function, like for the set counting set bit, built-in pop count. LL is for the long if the number is 64 bits, otherwise you can use only LL, only you remove the LL, right? Let me show that one also. Count is equal to set bits of n, right, and return count. If the number is 31, let's turn it. So like it is an one line answer for the counting the bits, like it's return 5, and for 30 it's return 4, it will return 4, right? Yeah, it return 4. So like this is an implementation for the counting the set bits in a number, right? Yeah. So we have discussed this also, and now we will let's move on to the count, check whether the current number is a power of 2 or not, right? Yeah, if let's suppose two numbers, let's take two numbers. First number is 8, we know this is the power of 2, right? And its representation is 1 0 0 0, right? 1 2 4 8, yeah. And another number, let's it be 6, okay, 0, let's take it more clear, 1 11, right? It will become 1 8 9, and this 9 11, yeah, 3, yeah, it become 11, right? So this is not, as we know, like we know, like this is the power of 2 raised to power 3, and this is not how we can do it via the bit operators, right? So in the bit, like how we can use it, like one way is like we can run a loop and check whether this number contains only 2 as a divisor, right? When at 8 divided by 2 is equal to 4 divided by 2 is equal to 2 divided by 2 is equal to 1, right? In the way I didn't get any odd number here, sorry, any odd number here, right? I get 1, this is the endpoint, right? If the number is 6, then when I divided by 6 by 2, it get me 3, which is wrong, because if the number is power of 2, then it contains only 2 as a multiple. So this is the way, like let's implement this first, how we can implement this logic, right? Okay, check power, right? So like what we will do, like it will be in integer, okay, we will return 1 if it is power of not, right? So while n is not equal to 1, what we will do, we will, like what we have to do, if the power is 2 or not, what we will do, we will just divide it by 2, n by 2, and like this, we will just divide it n by 2. If we can run this here, if n and 1, if the number is odd, return 0, otherwise return 1, right? Let's check it. Let's check for 30 what is the answer. It doesn't, yeah, okay, it returns 0. And if I check for 8, okay, it is not returning anything, right? um what is I have taken input n, and n is not equal to 1. Okay, while n is more than 1, let's run it. Okay, like it is going as an infinite loop, I guess, because that's the only reason it is not running the answer. Okay, that this function, okay, sorry, like I've written the wrong name. Okay, like 8, I've got the answer because this is the this is an power of 2, and if I check for 30, then it might return the answer 0, because that is not the power of 2. Yeah, it returns 0. So this is an quick implementation of checking, but let's move on to an efficient way. So what it can be, like, you can notice if the number is power of 2, then it contains only single set bit. If you check for 64, then it contain only 1 0 0 0 0 0 0. That means it has only single set bit, right? So we can all directly check it, like when I do the -1, then it will, what it will become, it will become 0, and rest all will become 1, right? And when I do the AND of this, then it must return 0, right? So this is the only thing I have to do. Like it has also the base case, if n is equal to 0, return 0, because that is not a power of 2, but that 0 and 0 minus 1, because definitely it will return true. Okay, so what I will do, return n and n minus 1, n and n minus 1 is equal to 0. अगर n and n minus 1 0 है, मीन्स n का एंड हमने उसके n माइनस 1 के साथ किया, मतलब 8 का 4 का एंड मैंने 4 माइनस 1 के साथ किया, और अगर 0 आया तो मतलब ये 2 की पावर है. अदरवाइज अगर मैं इसका एंड n माइनस 1 के साथ करूँ, वो क्या होगा, 1 0 1 0, ये है 10. ठीक है, तो मैं इसको जब माइनस का एंड करूँगा तो बस ये वाला बिट 0 होगा, बाकी सारे 1 0 1 रहेंगे. तो इसका मतलब ये एक 2 की पावर नहीं है. So like this is an efficient way in constant complexity, right? So let's run it. For 16, it must return 1. It return 0. Seriously, n and n minus 1 is equal to 0. Got it right. If n and n minus 1 is equal to 0, then we can do count plus plus return count. Like this must not affect anything, but let me try this. For 16, it must return 1. Yeah, it return 1. And for 15, it must return 0. Yeah, it returned. Like this is in a constant, like checking the power in the constant complexity. Like this, we can also check by this operator. Like if the set bits in n is equal to 1, like if the only it has only set bit equal to 1, then we will return count plus plus, and we will return 1. Like 15 has more than set bits, if I have to check for 16, then it will return 1. Okay, it hasn't returned anything. Why? Sound set bits of n is equal to 1 is and okay, I have one more bracket, like, sorry, then 16 for it, yeah, it is 1. So this is like a constant time complexity operation here, right? We can check. And yeah, this is done for today video, and the practice question is in the description. You can definitely check it out, and there will be an editorial video at the end of, like, for this topic, like basics for the bits, and then we will move on to the some medium and hard level question. Like, we will study about the how we can check for the every bits, like 32 bits and 64 bits continuously, and do some operators. And yeah, and like level increasing day by day. Like, this is now we are running on the easy level. And yeah, this is in collaboration with the Nutanix school. Yeah, you can definitely check it out, their website. And this is an online ID. You can run it by logging it, and uh, go to the playground and use it, right? It is super cool. Yeah. So till then, thank you and happy coding. Yeah, do the homework.